Here we go.
Oh my gosh. Isn't that a cute snowflake? Like it should be soy right now. It's not. Yeah. Alright. So 6C is arithmetic sequences. Now, if you do look in your book, you'll see there's a C1 and a C2. Today's notes should cover everything you need, but I'm only going to assign the C1 work today. So there's not going to be separate notes for C2. C2 is kind of application, so we're going to learn kind of the basics today of arithmetic sequences, the formulas that we will use for that, and then tomorrow C2, there won't be any new examples, but it will be taking like a word problem and using that word problem in your arithmetic sequence formulas.
Did you guys all get your stat box? Why won't this go? All right. So when we're working with arithmetic sequences, each term differs from the previous term by the same amount. This amount is called the common difference. So what does difference make you think of that word? Subtraction. What operation also goes along with subtraction? Division, sort of. But what's the opposite of subtraction? Addition. So these sequences, even though it's the common difference, and we'll look at a tiny little formula that sort of explains why we use the term difference instead of like sum, but these are going to be the types of sequences that to get the next number, you keep adding the same thing. Again, I'll explain a little bit more of why we use the word difference, but where we keep adding the same thing, and we use the letter D to represent that common difference. That's whatever it is that we're adding to get to the next term. Now, you can add a positive number or you can add a negative number to keep getting that next term. Okay, so this formula is not in your packet, but honestly, it's something that you will memorize very quickly. So going back to what we talked about yesterday, what does U sub n mean? What does U sub n mean? The nth term. So what does n plus 1 mean? The number of terms, what was that? The nth term plus 1, the next term. So all this is saying is that a term minus the previous term will give the common difference. So I don't know that you really need to memorize this formula, go ahead and write it down, but basically you take a number, you minus the number that came before it. And that's where that word difference comes, because we're subtracting to find what that is. So that's how you can find, if you've got a list of numbers, you can find the common difference by taking a number and subtracting the number that came before it. So this is straight out of your textbook, so I don't feel like you necessarily need to write it down, but I just wanted you guys to know where the term arithmetic came from. So, and we're going to actually we'll use a little bit of this in solving some of our problems a little bit later. But if A, B, and C are any consecutive terms in an arithmetic sequence, so I have a list and I have term A, or not, like the first term, the second term, and the third term are A, B, and C. If you equate the common differences, so B minus A, term minus the term before it, will equal the same thing as, come back, okay, will equal the same thing as if I take C minus B, because a number minus the number before it's going to have the same common difference, because we are adding the same thing. So if we set those equal to each other, because they're going to be equal, again, we're going to use that equating common differences on at least one type of problem later. And we kind of bring everything together. If I bring my B's over to the one side and bring my A over to the right, I end up with B equaling A plus C divided by 2. Well, that's the arithmetic mean, or like the average. You you guys remember taking the average of something? You add up all the pieces and you divide by how many? Well, I'm adding up two things, A and C, and dividing by 2. So that's where that term arithmetic kind of comes from, is that to find that middle term, it's actually the average of the other two. So we're not going to use this too much, but to find B is halfway between A and C, so it's the arithmetic mean. Just a little extra knowledge for you. And here's the most important formula for this section. So it's the general term formula for arithmetic sequences. So yesterday we worked with general terms, and we just gave you the general term. We said, here, this is the formula, this is the formula, this is what it is. Well, for today, what we're going to do is we can take a sequence, and we can actually write the general term ourselves using this formula. And so you'll notice I did say that this is in your formula packet. You should take a look and find it. It's under topic 1, algebra. And so this is the formula. U sub n equals U sub 1 plus the quantity of n minus 1 times the common difference. So U sub n is the n stands for our term number. So the n is the term number. So when we use n, that means we can have any term, right? But let's say I have to find the 5th term, I would have to put 5 in the n spot. Or if I'm asked to find the 100th term, I would put 100 in the n spot. U sub 1, like we talked about yesterday, that's the very first term, the first number in the sequence. These parentheses are extremely important. In the parentheses, we have n minus 1. Remember, n is our term number, so this quantity, n minus 1, ends up being 1 less than the term number. And once we have 1 less than the term number, we multiply that by the common difference, which we already talked about. We find the common difference by taking a number and subtracting the number that comes before it. You don't have to memorize this formula, but we're going to use it in a bunch of different ways today. We're going to write equations, and then once we write equations, we'll use them to find different terms. Any questions? The most common mistake that I see students making when they use this formula has nothing to do with the formula. It has to do with not following the order of operations, because we have to do what's in the parentheses first, and then we have to multiply before we can add. So that's the biggest thing, is I see people adding these numbers and timesing these numbers without ignoring the parentheses. So make sure you've got your parentheses in there and you can see those. So here we start. Example 1, we're going to consider this sequence. We're actually going to use this same sequence and do a bunch of different things. We're going to actually have 5 parts. So the sequence we're going to take a look at is 87, 83, 79, 75, 71, and so on. Now we're going to start with the show that problem. So show that it is arithmetic. Now, in the show that problem, we got to show our work, right? So we have to show that we have a common difference here. So what we're going to do in order to show that is take a number and subtract the number that comes before it to come up with that common difference. So I'll take 83 minus the number that comes before it, 87. And I end up with -4. And I'm going to repeat that process to show that I keep getting the same common difference as we move forward here. So I can keep going and do 79 minus 83. Sure enough, I get -4. What happens when I do 75 minus 79? Beautiful, -4. And if I finish out that last one, 71 minus 75 equals -4. So I understand that you guys can figure that out in your head, but because this is a show that problem, we do have to show our work, kind of prove it. Yes, we've got an arithmetic sequence. So the common difference is -4. first term. $87. That first term is 87. I just wanted you guys to kind of keep that in mind, and we're going to use that as we move forward. So identify that first term also helps, and then we know the common difference. We show that we've got the same common difference with all of those terms in our sequence so far. Okay. So 87 is our first term because it's the very first number in our list. Okay, good question. We gotta know that. So again, I'm gonna keep using the same sequence, so that same set of numbers. And I left that up there because I'm going to find the formula for the general term. Now I'm just gonna rewrite the formula up here. You should have your packet out so you can take a look at that. But so remember, this is my formula. So I just rewrote the formula straight out of the packet. And what we will do is we will plug in the numbers that we know. Now it's the general term, so I'm not going to know what n is. N will stay n. I'm just going to plug in my first term, plug in my common difference, and then I can do a little bit of simplifying to make it a little bit nicer. So I end up with u sub n equals 87 plus n minus 1 times negative 4. Anyone having any issues with plugging that stuff in? So in order to simplify, then I can distribute. So I can take that negative 4 and multiply it to what's in parentheses. So I've got u sub n equals 87 plus negative 4n plus 4, because that negative 4 times negative 1 will become positive. And then I can combine my like terms, so I end up with negative 4n plus 91 as my general term. Once we have this formula, then we can use it to do a few different things. So that's what we're going to do coming up here. But just a review, you had to substitute. That's what we did first, and then we had to simplify. So if you guys wanted steps, those would be the steps that I would say to follow. Are we okay? Someone check on it. Okay. So same sequence. I shouldn't have erased the general term. Actually, I'll move it up. But we want to find the 25th term. I'm just going to write down what we had already did. We had u sub n equals negative 4n plus 91. So there's two different ways to do this. One way is using the work we already did, which is why I wrote down that formula. So if I'm finding the 25th term, 25 goes in for n. Remember how I said n was the term number and when we had the big formula? So n is the term number, so I'm trying to find the number that's in the 25th spot. So I plug in 25 for n. So u sub 25 equals negative 4 times 25 plus 91. And then after that, we can simplify. So using our order of operations, negative 4 times 25 is negative 100. And negative 100 plus 91 is negative 9. So the 25th number in our list, if we keep adding negative 4 and adding negative 4, the 25th number will be negative 9. Now, I know we talked about yesterday that our term numbers can't be negative. So, like, the term number, down here, this 25 is never going to be negative, but my actual terms can be. So just to clarify that from yesterday to hopefully not have any confusion. Just to throw this out there, if you didn't already find the general term, you could go back to the formula that's in our packet and just plug everything in there. So u sub n equals u sub 1 plus n minus 1 times the common difference. You could just plug everything in here and have u sub 25 equals the first term 87 plus 25 minus 1 times negative 4. So like if you didn't have this general term, like let's say the problem didn't ask you to find the general term, you could plug everything that you know into that original equation that's in your packet and have 87 plus 24 times negative 4, which is 87 plus negative 96, and you still get negative 9. So just to show you like another way to solve that problem, putting both of those out there just so you're ready for whatever you come across. It'll depend on some questions. So that's a good question. Will it be all three of these steps? Some questions might just ask for the general term. Some might skip to a question like this.
But then, like, if it skips to, like, find the term like that, but we still have to do the first step to find the
Well, you could do this half. You know, like I said, so if you didn't want to find the general term, you could plug everything into this formula that's in your packet.
Yeah, but we would have to do part A, though, because of the D, right?
Or just one time, though. You wouldn't necessarily have to do it all 4 times. You could just do one time. Just do 83 minus.
83 minus, okay.
Does that make sense?
Yeah.
Okay, very good question. All right, we are going to keep the same. Where am I here? Come on. I don't know what's going on. Oh. So same sequence, but in this case, we are going to find which term in the sequence is negative 297. So which term in our sequence is negative 297? So what I'm looking for, so which term, I'm actually looking for the term number. I don't know what the term number is. I want to know where in that list will 297 be. Is it going to be the 10th term? Is it going to be the 100th term? Like where in this list will that be? So what we have to do is we have to plug in negative 297 for u sub n. For that whole thing, not just for the n. I'm trying to find n. But that's the term. We have the term, we're trying to find the term number. You could also do this one two different ways as well. I'm just going to use this general term formula, but you could use the original formula, plug in your first term and your common difference and all that, okay? So I end up with negative 297 equals negative 4n plus 91. So then I can just use my solving equation skills, subtract 91, and get negative 388 equals negative 4n. And I end up with 97 equals n. Which means my answer then is that negative 297 is actually the 97th term. So which term? The 97th term. If I keep subtracting 4, the 97th number in my list is negative 297. I know that there's a lot going on in this section, so please keep asking questions. If you've got them, if you want some clarification, let me know.
Technically, this would could end up with a negative number if they gave us like a term that came before the sequence starts. Or will they just not do that? Or is that no solution if that is correct? Ooh, Taylor.
So you're saying what is 87 plus 4? You're saying if they gave you
it would have given us a negative answer. Or if we get a negative answer, it would just be like no solution.
Ew.
Because it didn't start.
Right. So we will actually kind of cover that on the next example. in a different way, but it's related to what you're asking. So we'll keep that in mind as we do the next example. And you guys heard me when I said you could also go back to the general formulas in your packet and plug in all three things if you don't have this one, without me doing it twice? Okay. So this one's sort of like Taylor's question, because the question is negative 60 a member of the sequence? So the question would be like, is 90 whatever a member of the sequence? Well, you can't have a negative number if that would have happened. So we kind of set this one up the same way, where we want to know if it's a member of the sequence. So this is a term, so it's going to go in for u sub n, and we're going to look at what n is. So I'm rewriting, I had u sub n equals negative 4n plus 91. So I'm still looking for n. I've got negative 60 equals negative 4n plus 91. I've got negative 151 equals negative 4n when I subtract the 91. In my divide, I end up with 37.75 equals n. So that's the deal. This is not a positive integer. So then the answer is no, it's not in my sequence. And so if you ended up with a situation that Taylor explained, then you would end up with a negative number, so you'd still say no, it's not a member of our sequence. Now, if this came out to be positive, then we would say yes, it is a member of our sequence. We're going to do the stop box, and then we actually have two other examples after that.
I was about to say, I was really confused for a second. It's positive, it's just not an integer.
Oh, but it's not a positive integer.
You said if it came out to be positive, it would be.
Yeah. If it came, oh yeah, thank you.
Yeah.
Thank you. So if it came out as an integer. I was thinking about your question, not this question. Okay. So if it did come out to be just 37, if it came out to be 38 or an integer, then it would be yes.
Oh.
Yeah, I think I was just thinking about your question when I answered that. All right. Keep asking these questions. Any other questions? All right, so again, we do still have two more examples, but we're going to stop at the stop box first, because these examples are kind of unrelated. We're going to have different stuff here. So in your stop box, write down how you find what is the common difference, and then how do you find it. So you can definitely use your own words. You don't necessarily have to write down that formula. Like I said, I don't think the formula is as useful as actually understanding how to find it. To find the common difference. Sort of. Well, plug in. So which formula are you talking about? For the common difference, you have the number minus the number before.
Oh. It's the radio
So I'm hoping everyone said to find the common difference, you take a number and you minus the number that comes before it. Okay. Are you ready for a funky one? And I got so many people sleeping. You guys bring the lights on? Wait, sleep up.
It's a rough day. It is very
bio. Blame it all on the bio.
Yeah. Oh yeah.
So you're good? You're already over it?
I feel like this is a good chapter. So.
Okay, so this is a funky. We're gonna do two funky examples, and then we're gonna end the section here. So it says find k given that 5, k, and k squared minus 8 are consecutive terms. This is where I mentioned that we will use it a little bit. So we are actually going to use that equating common differences. So I know I brought that up when I explained why it's called arithmetic. We're going to just use that a little bit here. We're going to equate common differences. So, what does equate mean? Hey, what's equate mean? Equal, okay. So I just have to equate my common differences. So one of them has to be k minus 5. And then the other one is k squared minus 8 minus k. Be careful with your expressions. Keep in mind if you are subtracting an expression, you should use parentheses. I know we don't see that in this particular problem.
Bless you.
So now that I've got this, what are your thoughts? So you should see some things that you recognize. There's a squared. What does a squared mean to us? Potentially factoring, or if you're a complete the square lover, you can complete the square. Or if you hate both, you can use quadratic formula. But what we do have to do is bring everything over to one side. I am personally a strong advocate for keeping the k term positive. It just makes sense to me. So I'm going to bring this stuff over. I'm going to subtract k. So I'll still have k squared. A negative k minus k is going to be negative 2k. If I'm minusing this k. And then if I add the 5, I end up with minus 3.
I hate this chapter now.
It just shows up a little bit. Actually, you guys probably aren't going to like the next example either. But it's not factoring. And I've said this, I feel like a dozen times, maybe it's only been a half dozen times, how stuff we've done in the past keeps creeping back up. So we did quadratics in chapter 1, and looky here, we have to solve a quadratic. So you can use quadratic formula. I can't stress that enough. If you like quadratic formula, use quadratic formula. I see it's just a 1 here, so I'm going to think of factors of negative 3 that combine to get negative 2. So what are the factors of negative 3 that combine to equal negative 2? Minus 3 and plus 1. So then I can split this up into k minus 3 equals 0 and k plus 1 equals 0. It's that null factor law. So in this case, k could be 3 or k could be negative 1. So there's actually 2 potential answers for k. Okay, I think the last one is the most complicated. We still have 15 minutes, and it's not going to take a full 15, but it's probably the most complicated. So are you ready? Do you need to take a deep breath or anything? Any questions on this one before I move on? Once you equate that common difference, it's stuff like we said, we learned in chapter 1. Are you guys ready? No. Come on. One last one. Okay, so it's find the general term, but we don't have a list of numbers. Instead, I know u sub 5 equals negative 2, and u sub 12 equals negative 12 and a half. Right. What does u sub 5 mean again? The fifth term, so n is 5. And then u sub 12 means 12th term. I cannot just subtract to find my common difference because exactly, it's not like the 4th term and the 5th term and I can subtract them. So I can still find my common difference. And that's going to be the first thing I do is find the common difference. But what I'm going to do is write equations. So do you guys remember, I'm just going to write it down that we got today. So plus n minus 1 times d. So what I can do is actually write an equation for both of these. So I can take u sub 5 and I can plug that in. So I've got u sub 5. Wait a second, that's not what I want to put in. So I don't know what my first term is. What's n? If I've got u sub 5, what's n? And I don't know my common difference. But I know my fifth term is negative 2, so this negative 2 actually goes in the u sub n spot. My fifth term is negative 2. I can do the same thing here, where my 12th term is negative 12 and a half. So my n is 12, so 12 minus 1 times that common difference. So it's definitely weird. It's not quite like the other ones, and this is solving systems, which we did in that prior knowledge section. So what we're going to have to try and cancel something out here, but we also need to do some simplifying. Before I start doing that, are there questions? Because again, it is kind of funky with where we have to put some of this stuff. And it's really starting to understand what that terminology means. So it's the fifth term, so I put the negative 2 here because that's the actual term. 5 is the term number. All right, so I'm going to multiply this out, or not multiply it out, but add that, so it ends up being negative 2 equals u sub 1 plus 4d for my first equation. Same thing on the next one, so negative 12.5 equals u sub 1 plus 11d. Now, when we solve systems, we can do graphing, which we're not going to do here. We could do substitution, or we could do elimination. I know I've been like really upfront with I'm a person that really likes elimination. Do you guys see anything that could be eliminated relatively easily? The use of ones. I just have to change the signs on one of my equations. So I'm just going to change the signs on my second one here so that I have something that cancels out. So if I change that to positive, this becomes negative u sub 1 and negative 11d. Then these u's will cancel out, and I'll be able to find my common difference. So then those cancel out. If I do negative 2 plus 12.5, I've got 10.5. And 4 plus negative 11 is negative 7. So I have 10.5 equals negative 7d. And if I divide, I think I get negative 1.5. You guys with me on that? Now remember, we're trying to write our general term. So I know what d is. I can plug d in, but I still have to find the first term. So I've got to substitute that back in order to find my first term. Now you can pick your favorite. My favorite is the top blue equation because there are no decimals. So I'm going to substitute that back in right here. So I've got negative 2 equals u sub 1 plus 4 times 1.5. I just subtracted 5 minus 1 right away. Is that okay? Oh my gosh. Stay awake. Stay looking at us. So I end up with negative 2 equals u sub 1 plus, wait, am I missing something here? Oh, it's a negative 1.5. Good. So then that's plus negative 6. So if I add 6, 4 equals u sub 1. So you guys, I know I heard over there you guys caught that I accidentally dropped the negative at first. It's negative 1.5. Now that I have those two parts, I can write my general term. So my general term is u sub n equals my first term, which is 4, plus n minus 1 times my common difference, which is negative 1.5. So that's my final answer because that is the general term. Actually, I can do a little bit more. What did I forget to do? I was so excited to get done. Yeah. Do you guys get that way sometimes? You're like, I wish I was done, but I'm not done.
This whole note.
I know, they're long ones. So I've got 4 minus 1.5n plus 1.5, and then when I combine those like terms. Nope, not 4.
This whole problem took up like 1 page on mine.
I know. So you know there's not going to be like a billion of those, right? There'll just be like a couple. Alright, that's our best answer. When we actually do simplify that, that is a little bit better. So again, if you really like the other stuff, these just show up a little bit. If I even take a look at your assignment, you've got 2 of them like this. So you will be okay. So it's mostly that other stuff, just a couple of them where you've got to push it and think a little bit more and use some of your other skills. Do you guys do your math in all your other classes?
Yes. Yeah.
Why don't you just do the class in the class and then you can ask the teacher?
Okay,
I ran out
this
of
is a
studying.
test, so you
Just
kind
cram
of
it.
gotta do it now. Yeah, I feel like math I can do at home like comfortably. Because they're working so much. You put too many problems in them. I already noticed.
You guys got practice. You had it easy the past couple of days, right?
We should have had it easy today. And
This was so
That's the exact thing. I think that when we do hard lessons, they're always on that day.